Hey everyone, this is Jonathan from SAS Machine Learning and Artificial Intelligence. SAS Visual Data Mining and Machine Learning, affectionately known as VDMML, provides an automated, open, and most importantly, transparent and explainable experience for both business users and data scientists. Unlike many of our competitors, VDMML is not black box. Today I'd like to show you how SAS automation is transforming the machine learning landscape. Let's take a look at VDMML in action. I've logged into VDMML, and in front of us we have a dynamic pipeline. This pipeline was automatically generated based on the data I loaded to the system. Now the types of techniques that are available to you are feature engineering, dimension reduction, feature extraction, to many different machine learning techniques. The system will find the most optimal solution based on your data. Now how did we get there? Through the ability of adding a pipeline. I can either add a pipeline from the SAS Exchange. Now, over the years, you've seen how the SAS Exchange provides you with the ability to add in templates from other users. So you can add in best practices from one of your data scientist colleagues, or you can even add in best practices from SAS. SAS provides out-of-the-box templates for you to use inside your analysis. The Exchange is a wonderful place for collaboration. Now what we've added here is the ability to automatically generate pipelines. So once I hit the OK button, an intelligent process is underway. The system, depending on the type of data that I load, will intelligently determine what the right set of transformations, the optimal set of features to help predict my outcome. Now as it's going through this process, it's continually benchmarking. So as it finds a set of transformations, a set of features that it wants to use in its models, it will continue to benchmark and then build another model. So for example, as it's determining the right set of features, it will add in a gradient boosting model. It will then add in a forest, and it will optimally tune those features to find the best solution. And this is an iterative process. So as it finds an algorithm that helps predict the outcome, it may go back and try additional features. So again, this is a continuous process that will run through hundreds, if not thousands, of permutations to help find the optimal solution. And as this is running through, you're presented with an automated status. So the status that you are presented with is real time. Gives you an indication of where it is in the process. So it looks like it's completed. Let's take a look at the results. And as we can see here, it automatically drew a pipeline. Now there's different types of transformations that it generated, different algorithms. So for example, it ran decision trees, and in this case, logistic regression. And you'll notice here that it ensembled a handful of the models. It didn't just ensemble everything, it determined the smart way to ensemble to find the best solution. Now let's take a look at what the system will generate once it's completed. Now if we go back to my original pipeline, we can see here that the system ran through different permutations. And the model that it chose was an ensemble model. And if we take a look at the results, you're presented with different types of score code. You're presented with assessment information. Now, typically, when a data scientist is analyzing their results, they're very comfortable with what a lift chart means. But if you're a business analyst, it's possible that you don't understand what cumulative lift is. You don't understand what an ROC plot is. So as I click through the system, there's little info helpers. So for example, I clicked on cumulative lift, and you'll notice through the use of natural language, the system presented a natural language understanding. So for example, you can see here that the validate partition has a cumulative lift of 1.84 in the top decile, for example. But this helps explain to me why this particular metric was important and how to interpret it. Now it's dynamic. So for example, if you have new data and the system has determined a different model, has run through different properties, the explanation will be different. So as I'm clicking throughout the system, I'm provided with different explanations. Now, model interpretability. Model interpretability is critical when understanding the validity of a model. For those of you out there that are not familiar with such techniques as LIME, ICE, partial dependency, kernel SHAP, these are very popular methods in the market to help describe from a surrogate perspective what the important factors are in your model. So inside the system, you're presented with partial dependency plots. So if I'm an analyst, if I'm a business analyst, it's very easy to understand from a what-if perspective, what happens if my behavior score changes? My prediction changes accordingly. For example, if I click on a different product, you can see here that if I have the lavender product, I have the highest probability. And again, if I'm not sure how to interpret this information, the system provides me with a real-time readout in interpretability. Now, we also have many other advanced techniques from LIME, ICE, kernel SHAP. These allow you to go even deeper into individual observations. So again, I don't need to be a data scientist in this case to understand how to interpret these models. Now, it's important to note that the system provided an automated readout or an automated pipeline for me to be able to interpret or to build the most accurate model. But I mentioned that this is not black box, and this is also customizable. So you have the ability, for example, to add in, let's say, SAS code. If I wanted to amend my analysis or extend it, I can add in additional SAS code. I can also add in open source code. So this system is also open to different languages, from Python to R. So if you have other data scientists on your team and they want to amend the analysis, they want to add to the analysis, they can bring in other open source techniques. Now, once you're quote unquote done, this could have taken days, this could have taken weeks, because this is an iterative process. Perhaps there's approval processes that you want to run through. Model deployment is critical. And this system certainly has many ways to deploy models, from one click to REST APIs to in-database, in-Hadoop processes. But let's say you're a business analyst and you want to be able to explain this to the rest of the business through the use of automated insights. Automated insights allow you to be able to communicate this information to a wider audience. So when I clicked on Insights, you'll notice that the system dynamically generated what I like to call, it's almost a book report. This is a summary of everything that I've done today inside this analysis. And through the use of natural language, this gives me an indication of the most important factors. But this also has natural language built in. So again, if I'm not familiar with any one of these results, I can just click my little info helpers. So again, this system is intended for not only business users, but it's also intended for data scientists to work together with these business users. So I hope you enjoyed this quick tutorial on SAS automation. It's a really exciting time to join in and use VDMML. You can be a data scientist and write the most advanced machine learning models, but you can also be a business user. And through the use of SAS automation, you can take advantage of either SAS best practices or even best practices from your colleagues. And most importantly, you can communicate your findings and deploy your models to production. Thanks for joining.